Welcome to the Deep Dive, the show where we take a stack of dense source material, strip away the noise, and really deliver the concentrated insight you need to be well-informed fast.
We're here to guide you through the complexities, especially when, one particular narrative seems to dominate the conversation.
And today, we're tackling one of the most consequential biotechnological advancements and, let's be honest, one of the biggest social flashpoints of the last decade.
We're talking about the messenger RNA, or mRNA, platform. This technology went from, the laboratory fringes to global deployment almost overnight.
And with that speed, that rapidity, came some really profound scientific and ethical questions.
Exactly.
So our mission today is very specific. We're doing a deep, really detailed exploration of the critical perspective on this technology.
And we're drawing exclusively from the views and research of one particular scientist, Dr. Alexandra Henrion-Caude.
Right. She's a distinguished geneticist. She's become an activist. And she's the author of a pretty controversial book, The Sorcerer's Apprentice.
The material we're diving into today comes from a really extensive interview transcript. And in it, she doesn't just voice, general skepticism. She lays out the precise scientific nuances of RNA.
She critiques the history, too. The failures of the platform before 2020.
Yes, and she examines the ethical implications of its mass use, and she recounts the very personal cost of scientific dissent and what she calls censorship.
So this material, it really represents a deeply researched counter-narrative. It's essential for anyone who wants a truly holistic view of this whole global debate.
Right. We need to understand not just what the proponents are saying, but also the detailed molecular and historical objections that are being raised by credentialed scientists.
Okay, let's get into it. Let's unpack this.
Yeah.
So before we dive into all the controversy, we have to understand the molecule at the very center of this conversation, which is RNA. Dr. Henrion-Caude starts with this almost palpable sense of admiration for it. She says that for her, the passion, her scientific passion, isn't with DNA. It's with RNA.
Yeah, that's a key distinction.
As a geneticist, why? Why is this one molecule so favored?
Well, she offers this really compelling analogy to distinguish the two. She says to think of DNA as this master instruction manual, a huge structured book, but it's sitting closed and untouched in a library.
So it's the static information, the blueprint.
Exactly, the blueprint. It represents the fundamental code, but it's essentially passive. It doesn't do anything on its own.
So it's the permanent record, the archived code.
Precisely. RNA, on the other hand, is all about dynamism. It's the librarian who's actually pulled the book from the shelf, opened it up, and is actively reading specific chapters.
Translating them.
And reacting in real time. In her view, DNA provides the instructions, sure, but RNA is the molecular reality. It's the molecule that is actually executing the commands.
So it's reacting to the environment inside the cell.
Exactly. That's why she calls it the real code and the intermediary. It's the go-between, the active agent.
That makes RNA sound like, I don't know, the ultimate multitasker. It's highly functional, but maybe also highly vulnerable.
Oh, it's far more versatile than DNA, which is, mostly just that stable double helix. RNA is single-stranded. That means it can be short, it can be long, and critically, it can fold itself into these incredibly complex and variable shapes.
Like origami?
Kind of, yeah. These different shapes, these secondary and tertiary structures, they allow it to perform all these dynamic functions. It can act as an enzyme. It can be a regulatory element.
It's a real workhorse molecule.
It is. And this inherent reactivity and capability within the cell is what she says initially captured her scientific heart. She sees it as a molecule of profound capability, almost mysterious in its ability to adapt. Hashtag 1.2, the unexpected path to authorship.
And it's that deep scientific appreciation for RNA that makes her whole path to becoming an author so unexpected. She wasn't looking for a public role. She was a researcher.
Right. She wasn't seeking the spotlight. She actually recounts being pursued by an editor, approached twice in the street by a representative who just insisted she had to write a book.
And what gives the story so much context is the publisher.
Yes, Alba Michel. In the source, it's described as a major establishment French publishing house. The kind that publishes political heavyweights, figures of institutional authority.
The establishment, basically.
Totally. The fact that a critical book, a book arguing against the establishment scientific narrative, came from within that establishment ecosystem, that is highly, highly unusual.
And she was ready for them to just reject her idea. Right. She insisted the only topic she would ever write about was RNA.
She was expecting an immediate shutdown, the same kind of shutdown she'd gotten from colleagues in the early days of the global health crisis. But, by that time, the world was suddenly hungry for information on RNA.
So they said yes.
They accepted the topic. And the process that followed, she describes it as intensely rigorous. She notes that the publisher checked the manuscript not just for scientific clarity, but with lawyers.
To make sure it was legally sound.
Exactly. And they found that all of her sources were verifiable. They were either drawn from established scientific literature or from documented mainstream media information.
So everything was checkable.
Right. And she emphasizes that this meticulous sourcing is what allowed a book with such a critical, non-mainstream viewpoint to actually be released by such a respected high-level press.
So she had the verification. She had the major publisher. The topic was timely. The publisher must have been expecting a bestseller. They prepared for a standard marketing campaign.
A full promotional blitz. Media tours, interviews, the works. But the moment the book hit the market,
The commercial campaign failed. Spectacularly.
the publisher was reportedly just stunned by the intensity of the aggressive negative treatment she got from media outlets. She described the treatment as relentlessly opposing and at times, bordering on outright insult.
So they pulled the plug.
The campaign was eventually halted by the publisher. Yeah, they acknowledged the treatment was just terrible and it was unsustainable. Hashtag 1.3, the immediate media backlash and censorship.
And this narrative of censorship in the source material is powerful because she claims this punitive media behavior started incredibly early.
In February 2020.
Right, before the pandemic was even officially declared. She asserts she was the very first scientist censored in France on this topic.
Which points to, in her view, a coordinated mechanism. She suggests the mainstream media were operating under some kind of guidance system, a do not invite list.
Almost like a security alert instructing outlets to just avoid her.
Yes. And she states this mechanism was later confirmed to her by people working inside the media in Holland. It suggests it was an organized, maybe even international phenomenon, not just a bunch of individual editorial decisions.
That raises a pretty chilling question about the scope of scientific discourse that was allowed during a global crisis.
Yeah.
What was the personal cost of this dissent for her?
Well, she shares this truly striking anecdote about her reputation.
Her reputation destruction.
It's the highest cost a scientist can pay. She recounts her own former mentor, someone she held in very high regard, speaking out against her.
What did he say?
The mentor said, and I'm paraphrasing here, something like, "I don't know what happened to her. She was the brightest student I ever had. She was right. And then suddenly she became, and just trailed off."
The implication being that she didn't just disagree with the data, but that she somehow became intellectually corrupted or incompetent overnight.
That is the insidious nature of the attack.
Yeah.
It's not engaging with the scientific arguments. It's not looking at the historical data or the molecular critiques she's raising.
It just dismisses the source.
Exactly. It dismisses the source by implying this sudden, unexplained degradation of her intellectual capabilities simply because she dared to challenge the prevailing narrative.
That mechanism attacking the person rather than the argument, it's a textbook example of how you destroy reputation in the scientific community.
Yeah.
It's designed to isolate the dissenter.
Absolutely.
Okay, so that personal journey provides the vital context for why she wrote the book. Now let's pivot to the core technical and ethical disputes that drove her to publish, and it starts with the terminology itself.
The words we use.
For years, she was hesitant to get into the semantic battle over whether this product should be called a vaccine, but now she sees it as an essential fight, and one rooted in ethics.
Her primary argument is that the term vaccine is a scientific misnomer, and it's one that conceals a far more significant action. She insists that this technology is a genetic injection.
A process of introducing foreign genetic information into human cells.
Exactly.
And this leads directly to a very highly charged claim in her book, that this process effectively makes the recipient a genetic modified organism.
A GMO.
Right. I mean, that's a term we usually reserve for agricultural products like corn or soy. Could you elaborate on the precise definition she's using that makes this classification, in her view, appropriate for a human being?
It connects right back to the fundamental mechanism. She argues that the modified RNA doesn't just trigger some external immune response. It actively hijacks the cell's internal machinery.
Or ribosomes.
Ribosomes, yeah. And it compels them to continuously produce a specific foreign protein, like the spike protein.
So her definition of modified is that the cell's programming has been commandeered.
Precisely. In her definition, an organism is modified when its essential programming is commandeered to perform a function like this continuous protein production that was not part of its original stable genetic instruction set.
So the ethical line is crossed because the individual cells are being converted into these temporary self-producing factories for a non-human sequence.
That's her core ethical argument. She says that regardless of whether the resulting protein is toxic or not, it is inherently unethical to modify a human being to make them a factory to produce anything.
Without full disclosure.
Without absolute and transparent disclosure of this mechanism, which she argues did not happen under the simple, reassuring guise of the phrase, just a vaccine.
She sees the naming convention as deceitful.
Deeply, which is why she uses that French wordplay. She refers to the modified RNA as moni, which means liar, instead of messenger, which means messenger. Hashtag tag 2.1, the experimental status, and do no harm.
Okay, so beyond the terminology, the source material identifies the principle of do no harm as the primary motivation for writing the book.
The Hippocratic Oath.
Right. She states the evidence of injuries and harm sustained by people who received the injections was the initial catalyst for her.
And she anchors this concern in the product's historical status. This technology was deployed globally while Phase 3 trials, the crucial large-scale safety and efficacy checks, were still incomplete.
And she emphasizes that in the 2 decades of research before this, the mRNA platform had a record of being, in her words, a vast failure.
A vast failure, yeah.
Let's pause there because that historical context is so often missed. The public was presented with this idea that it was a cutting-edge, proven technology ready to go.
It was framed as an overnight success.
So what defined that 20-year history of failure?
Well, she details that no mRNA platform had ever succeeded past Phase 2 trials, ever. Across various disease targets, the research constantly ran into major roadblocks.
What kind of roadblock?
The failures were often due to issues like severe systemic toxicity in animal models, or poor protein stability, meaning the product just degraded too fast to be effective.
So it didn't last long enough.
Right. Or it would generate an inappropriate or even self-harming immune response. The technology was known within the field to be fundamentally unstable and incredibly difficult to deploy safely at scale.
And she contrasts this with established scientific success metrics.
She does. She notes that truly effective techniques, the ones that lead to successful pharmaceutical products, they typically deliver results within a decade.
But technologies that linger for 40 years,
Mm-hmm.
she brings up gene therapy as an example.
Which still hasn't provided routine cures for most diseases. She says those are usually considered stalled or ineffective.
So the fact that the mRNA platform had such a poor historical track record.
She argues it made it inherently irresponsible to administer to healthy populations on a massive global scale. It violated the core caution that's necessary when you're introducing experimental methods into healthy individuals.
It's the do no harm principle in action.
Exactly. First, do no harm. And here's where we move into the really technical specifics that she argues justify a moratorium on the whole platform.
Okay.
We need to look closely at the 2 main molecular mechanisms she identifies as creating systemic risk. First is the delivery system, and second is the unintended consequences of the RNA modification itself.
Let's start with the packaging, the thing that gets the genetic material into the cell, the lipid nanoparticles, or LNPs. The source implies these are far more than just, neutral transport vehicles.
No, indeed. The LNPs are essential because, as we said, standard mRNA is fragile. It would be immediately destroyed by the body's enzymes. So the LNPs function as this protective bubble.
A little fat bubble.
A little fat bubble, exactly. But they're made primarily of something called cationic lipids. These are lipids with a positive electrical charge. And this specific chemical structure is what allows them to adhere universally to the negatively charged cell membranes all throughout the body.
Wait, so the positive charge acts like a kind of molecular Velcro, allowing the LNP to stick to and invade pretty much any cell it bumps into.
Precisely. That's a great way to put it. This makes them systemic invaders. Unlike a traditional vaccine, which typically stays localized to the injection site and the surrounding lymph nodes to activate an immune response,
This stuff goes everywhere.
the LNP formulation ensures the mRNA payload is distributed everywhere. The LNPs can bypass barriers. They get into any cell, not just the immune cells.
And the sources confirmed that this widespread off-target distribution was known from the very earliest studies.
Yes, she points directly to early Pfizer studies that demonstrated this systemic invasion. The modified RNA was found distributed to the brain, the ovaries, the testicles, and, if the individual was pregnant, the placenta.
Which raises a pretty powerful critical question.
It does, she asks. If the goal is general immunity, what biological purpose does a vaccine serve by penetrating reproductive organs or the central nervous system? This off-target invasion is cited as a fundamental built-in risk mechanism.
On top of that, she claims the LNPs themselves, separate from the genetic payload, carry their own toxicity.
That claim is very strongly asserted. She says this toxicity was known since day one. She mentions that concerns about LNP toxicity were formally raised with the European Medical Agency.
And what was their response?
Well, the agency reportedly acknowledged the toxicity, but the initial response was that the risk would be minimal because, only 1 or 2 doses were anticipated.
Which quickly became obsolete.
Right, as populations receive 3, 4, 5, 10 shots. She also references past research where at certain dose levels, the nanoparticles alone caused 80% of test mice to die, which demonstrates the inherent danger of the delivery system before that dose was refined and lowered. Hashtag 3.2, the genetic modification and misreading.
Okay, now let's focus on the payload itself, the modified RNA. As you mentioned, natural RNA is delicate, it has a short half-life, it has a built-in off button. But the engineered mRNA is synthetically altered to be stable for distribution.
And this is a crucial pivot point in her critique. Normal mRNA is quickly degraded by cellular systems. It's supposed to be temporary. The modified mRNA is synthetically altered. It's a process called nucleotide modification to make it much more steady.
Which allows it to be stored at room temperature for longer.
Exactly. That stability was engineered for logistical feasibility for shipping and storage, but she argues it came at the direct expense of safety.
How does that compromise safety? What's the trade-off?
The trade-off is that by increasing the stability, you're essentially bypassing the body's natural defense mechanism, the ability to destroy foreign or temporary RNA quickly.
It can't get rid of it.
Right. The result is that the modified RNA and the spike protein it programs the cell to produce are found in the body for months and potentially years after the injection. And crucially, there is no known, reliable, predictable mechanism to stop that production once it starts.
The off button has been removed.
The off button is gone.
And this leads us to what she calls the misreading scandal. This claim is highly technical, but the core idea is that the synthetic modification causes the cell's machinery to read the genetic code incorrectly.
This is where we need to get very specific. The genetic language uses 4 chemical letters, or bases: adenine, uracil, guanine, and cytosine. AUGC.
The alphabet of life.
Exactly. In the modified mRNA, one of these bases is synthetic. Specifically, the uracil is replaced by something called pseudouridine.
And this modification was designed to do what?
It was designed to make the RNA less recognizable to the immune system, to make it stealthy so it could hang around longer and produce more protein without being attacked and destroyed.
But introducing a synthetic letter confuses the system.
That's her argument. When the cell's machinery, the ribosome, encounters this synthetic letter, she says it sometimes gets lost. The ribosome relies on a very precise reading frame. It has to start at a specific capital letter signal.
And the pseudouridine can mess that up.
It can cause the ribosome to skip or shift slightly. It's a phenomenon known as ribosomal frame shifting or slippage. So instead of starting the reading process at the intended starting point, the reading starts later.
And shifting the reading frame, even by 1 base, completely scrambles the resulting protein sequence. It's like a typo that changes the whole meaning.
It's worse than a typo. If you start reading in the wrong phase, the resulting words are different. This misreading leads to the production of what she calls fake proteins.
Fake proteins.
Sequences the body was never, ever intended to make, often just random or truncated polypeptides. She cites this production of novel, unintended proteins as the mechanism through which the body can build antibodies against its own cellular components.
Which could lead to?
Potentially many of the chronic diseases observed as secondary effects. And this technical discovery, this itself became part of the controversy.
How so?
She highlights that this specific finding, the one about systemic instability and misreading caused by the pseudouridine, was published in the journal Nature.
A top-tier journal.
The best. But it was published shortly after the scientists involved had received the Nobel Prize for their work on the platform.
Oh?
The timing, she suggests, represents a significant scandal. The fundamental flaw being acknowledged in the scientific literature only after the immense institutional validation of a Nobel Prize had already occurred.
Okay, so given the scale of these technical concerns, you've got the toxic delivery system, the widespread off-target distribution, and this misreading that leads to fake protein production.
Hmm.
The source argues that the only responsible course of action is an immediate and sweeping halt.
A global pause, yeah.
And she's not just talking about it. She has co-published a formal call for action.
Yes, she and her colleagues co-published a comprehensive moratorium at a high international level. She characterizes this as potentially the largest collective statement of dissent in the history of biomedical biology to date.
Wow. What is the scale of this unified scientific opposition? How many people are we talking about?
It's massive. The effort has gathered the support of over 2,500 medical scientists and clinicians.
And it's global.
It spans more than 60 countries, from Asia to Europe to the Americas. The scale of this unified scientific voice, including its partial publication in a major newspaper, the Berlin Zhongzhongwei, lends considerable moral and scientific weight to the demand for this global pause.
And the moratorium isn't limited to just the initial use, is that correct?
That's a vital point to note. While the platform has other theoretical applications like cancer therapy and oncology,
It sounds promising.
it does, but the concerns she's reviewing related to the LNP distribution, the chronic production of foreign proteins, the instability of the modified RNA, these are fundamental to the platform itself. They're not specific to one application.
So the flaws are baked in her view.
Exactly. Therefore, the call is for a moratorium on all uses of this specific mRNA platform until these deep molecular flaws can be properly understood and resolved. Hashtag TAC 4.2, the history of clinical failure.
And a key part of her argument rests on this historical precedent. She's suggesting that the rush to global deployment completely ignored decades of prior failure data.
She states that in her book, she takes the time to review the clinical trial history of mRNA technology, trial by trial. And she repeatedly arrives at the same conclusion: failure, sometimes resulting in patient death or severe adverse events.
This wasn't a technology that was just, waiting for its moment to shine.
No, it was a technology that was actively struggling to succeed.
Can you give a specific example of this failure that she cites?
Sure. She details a trial aimed at curing prostate cancer using an mRNA approach. This started way back around the year 2000,
So long before the pandemic.
20 years before. For 15 years, researchers invested heavily in this application, but the project ultimately concluded as a total failure.
Why did it fail?
Well, the reasons often included the inability to generate a lasting specific immune response against the cancer cells, or the systemic adverse effects just outweighed any potential therapeutic benefit.
So the side effects were worse than the disease it was trying to treat.
In many cases, yes. This history fundamentally challenges the narrative that the technology was mature or somehow guaranteed to succeed once it was deployed globally in 2020. It reframes the whole thing.
It reframes the deployment not as the culmination of some guaranteed success, but as a massive experimental leap based on a historically poor-performing platform.
That's exactly her point. Hashtag 4.3, the conflict of expert knowledge versus informed consent. And this leads us to what is arguably the most alarming ethical point raised in the entire source material.
Okay.
It's this conflict between expert knowledge and the absolute necessity of informed consent. She describes some shocking encounters with her professional colleagues.
She relates that some of these colleagues actually admitted to her that they were actively withholding full information about the experimental nature, the risks, the technical mechanisms of the platform.
Yes. She quotes these colleagues as saying directly to her, if we had been completely honest to people, they wouldn't have taken the vaccine. And this is presented not as some isolated incident, not one bad apple, but as reflective of a pervasive attitude within a segment of the medical establishment.
The source labels this as power abuse.
She views it as a kind of institutional paternalism. This attitude reflects the pervasive thought that we are the experts and the public isn't smart enough to handle the full information.
Especially about complex genetic tools.
Right, and therefore the public can't be trusted to make the correct decision for themselves or for society. She views this as a profound ethical breach.
That just violates the fundamental contract between a doctor and a patient in modern medicine.
Absolutely. She stresses that the patient must always be at the core of the health system, and they must always be given the free choice.
True informed consent.
It requires complete, transparent honesty about the experimental status, the known risks like the LNP toxicity and distribution, and the long-term unknowns like chronic protein production. The idea of forcing a solution onto a patient regardless of her own belief in its utility, is something she states she could never, ever be comfortable with.
So that profound ethical and technical conflict, it really pushed Dr. Henrion-Caude beyond the role of a traditional academic researcher and into the role of an activist.
A role she accepts. She defines it as fighting for freedom and opposing any attempt to be, as she says, put in a box.
Her activism was very focused, wasn't it? On opposing measures that felt forced or mandated onto people?
Extremely focused. This included lockdowns, forced vaccinations, and the widespread requirement for PCR testing. She described these mandates as being akin to being jailed in one's own home when people had committed no crime.
She recounts the difficulties of her early dissent, which really reflects the social pressure that was placed on anyone who questioned authority at the time.
Oh, yeah. She describes the initial demonstrations in Paris, which started with just 20 people. Just a tiny group. And even these small, peaceful gatherings were met with a heavy police presence, with heavy equipment.
Treating them how?
She said they were treated as if we were terrorists. And she noted this striking detail. Organizers had to wear their masks under their chins to avoid immediate arrest by the police for non-compliance.
Just to be able to speak.
Right. It just highlights the oppressive atmosphere surrounding public dissent at that time. Hashtag tag 5.2, the call for unity.
Despite all the divisions that were being fostered by the mandates, a key theme of her activism was this call for unity. She frequently shouted it to the crowds. Vaccinated, non-vaccinated, we are one people.
And she argues that this unifying message was deliberately suppressed by the mainstream narrative, which focused instead on creating these deep social divisions based on health choices.
Creating an us versus them.
Exactly.
Yeah.
In her view, the real danger during the crisis wasn't just the erosion of individual freedoms, but the fracturing of social unity, the ability to accept that we would disagree without resorting to ostracization and hatred.
That touches on the really sensitive issue of health intimacy and privacy.
She stresses that health intimacy, your vaccine status, your drug choices, your medical history is private. And it is, in her words, incorrect to discuss such personal matters in public settings, even at a family gathering.
And the forced public disclosure of private medical status.
It became weaponized for social control, and it contributed significantly to the erosion of trust and social cohesion.
She links this all back to health.
She does. She argues that freedom is intrinsically linked to health, that being non-stressed, autonomous, and free from external coercion is absolutely essential to living a healthy life. Hashtag tag 5.3 AO, message to the vaccinated.
Before concluding her argument, she shares this really profound message.
Yeah.
And it's aimed directly at a large segment of the population.
For people who did get the injection.
Yes, those who received the injection and are now worried about their fate after hearing about long-term technical issues like misreading or chronic protein production.
And she approaches this from a highly philosophical standpoint. It's designed to alleviate what's called iatrogenic stress, the anxiety caused by the medical intervention itself or the fear surrounding it.
And her message, intentionally blunt.
It is. She says, you're going to die just like me because we all end up.
Which is a surprising way to offer comfort, you might think.
It is, but she uses it to shift the perspective. She clarifies that the best definition of being alive is the acceptance that we will eventually die. The purpose of this is to alleviate the intense, permanent stress and anxiety associated with worrying about these irreversible molecular changes.
So she's trying to get people to stop worrying about something they can't change.
Exactly. Prompting people to recenter their focus on maximizing their present freedom and reducing that chronic gnawing fear. Hashtag tag outro.
You know, it is extremely tempting to want to put this entire period behind us, to just stop talking about the crisis, the mandates, the technology that dominated global life for so long.
Everyone wants to move on.
But after hearing the technical details laid out by Dr. Henrion-Caude, the systemic invasion caused by toxic LNPs, the misreading from pseudoridine that produces fake proteins, the lack of an off button, we have to confront the future implications of this platform.
And she highlights the critical reality that even if the public discussion fades, mRNA platforms are currently being built and deployed everywhere, globally, in numerous countries.
So if the critical engagement stops,
these platforms will continue to produce future mRNA products for a myriad of applications, both known and unknown.
And in her scientific view, allowing this continued proliferation without resolving the fundamental stability and off-target distribution issues is permanently harming people.
Correct. She argues it fundamentally disrespects the precise and complex nature of the human genetic system. She describes it as being just like a watch system, requiring extreme respect and care.
She also points out that the modified mRNA has been shown to persist and cross critical biological barriers.
Yes, being found in breast milk, reaching the placenta, where it can potentially enter the reproductive organs of a developing fetus. The potential for long-term transgenerational effects stemming from a platform with these known instabilities.
That's why she argues the critical engagement has to be maintained.
It must.
So, what does this all mean for you, the listener? This discussion is about more than just a single product. It's fundamentally about the structures of power surrounding scientific advancement, the integrity of our individual genetics, and the sacred nature of health autonomy.
The widespread, rapid deployment of a platform that has demonstrated this level of molecular instability and systemic off-target distribution means that critical, open, and detailed scientific engagement is still absolutely essential.
To protect future health policy and to protect individual choice. So the question we're left with is this. What stands out to you about the relationship between scientific advancement and individual choice in this new age of easily deployed genetic tools?
A profound area to explore as these technologies continue to integrate more and more into our lives.
Indeed. Thank you for joining us for this crucial deep dive into the critical perspectives on mRNA technology and scientific dissent.
We'll see you next time.